Students, in this video we will discuss some numericals about VT graph, DT graph. Here is a graph, VT graph, time along x-axis and velocity along y-axis, and graph is shown a straight line. In this graph we have to find what is acceleration and what is distance covered. What is distance covered? To find acceleration from VT graph, I have told in previous video, we have to find the slope. We have to find the slope. Acceleration, this is 0. Acceleration equal to slope of the graph. This is the slope. Final velocity 0, initial velocity 20. So final velocity minus initial velocity. 0 minus 20 or minus 20, and time is 5. This is 5. Minus 20 by 5, that equal to minus 4 meter per second. This is the acceleration of this graph, and distance covered is equal to area enclosed between the graph and time axis. Area enclosed between the graph and the time axis. This is the graph and this is time axis. So we have to find out this area. Means area of the triangle. Area of the triangle ABC. Distance equal to area of triangle ABC. Area of triangle equal to half base into altitude. Half base is AC and altitude is AB. AC 5, AB 20, 2 times 50 meters. So in this graph, acceleration is minus 4 meter per second square, and distance covered is 50 meter. Now I have written another question. We will discuss this question. A cyclist is cycling at a uniform rate of 8 meter per second for 8 seconds. He then stops pedaling and the cycle comes to rest in next 10 seconds. Draw VT graph, average gradation, distance covered with uniform velocity, distance covered with variable velocity, and average velocity of cyclist. These 5 things we will find out. Now I will erase the first one. First of all, we will draw the graph. A cyclist is cycling at a uniform rate of 8 meters per second. We will take velocity in meter per second along y-axis and time in second along x-axis. 2 meter per second, 4 meter per second, 6 meter per second, and 8 meter per second. For 8 seconds. 2 second, 4 second, 6, 8, 10, 12, 14, 16, 18. Cyclist is cycling at a uniform rate of 8 meter per second for 8 seconds. Up to 8 seconds, he travels with the same speed. He travels with the same speed. Means its speed does not change. That is uniform motion. Then he, up to 8 seconds, his speed remains constant, 8 meters per second. After that, he stops pedaling. When he stops pedaling, what will happen? The cycle will slow down, gradually speed decreases, and finally the cycle will come to rest. The cycle comes to rest in next 10 seconds. After 8 seconds, 10 seconds, 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds. That means at 18 seconds, the cycle comes to rest. This is the graph. Bit 1 completed. Bit 2. What is average retardation? In this part, the rate of decrease in velocity is called retardation. The rate of decrease in velocity is called retardation. The rate of increase in velocity is called acceleration. In this case, in this part of the graph, retardation takes place. So you give it name A, B, C, D, O. Slope of BC graph. Retardation is equal to slope of BC graph. Slope equal to y distance by x distance. Y distance by x distance means BD by CD. BD equal to 8 and CD equal to 10. CD equal to 18 minus 10, 18 minus 8, 8 by 10 means 0.8 meter per second square. Then in bit 3 it is asked you to find distance covered with uniform velocity. A to B, the velocity remains constant. This is the uniform velocity. So distance covered during uniform velocity, we have to find out the area of AB DO, area of AB DO. Distance covered with uniform velocity. The area of ABDO. ABDO is rectangle. Rectangle area equal to length into breadth. Means OD into OA. OD into OA. OD equal to 8 and OA equal to 8. 8 into 8. 64 meters. Then we have to find distance covered with the variable velocity. Distance covered with variable velocity. In which part velocity is variable? In BC part velocity is variable. So we have to find out the area enclosed between BC and time axis. That is equal to area of triangle BCD. Half base CD and altitude BD. Half CD into BD. Half CD equal to, this is 18, this is 8. 18 minus 8. And BD equal to 8. 2 4 जा 18 minus 8 10 10 into 4 40 meter. Distance covered with uniform velocity is 64 meter. Distance covered with variable velocity is 40 meter. Then what we have to find out? I will do it in top. Bit 5. Average velocity. Average velocity equal to total distance covered by total time taken. Total distance, how can we find out? This is 64 meter during the uniform velocity. This is 40 meter during the variable velocity. 64 plus 40. Total time taken is 18. 104 by 18. 18 5 90. 14. 18 7 is 126. Then 14. So 5.77 meter per second. Average velocity. Understand? How can we solve? How can we find displacement or distance, acceleration, retardation, and average velocity? How can we find from the graph? And also, question, if question given, how can we draw the graph? These are discussed we now. In the next video, we will discuss about the various formulas of distance. V equal to U plus AT, S equal to UT plus half AT square, and V square equal to U square plus 2S. These are the formula of motion. Next video we will discuss. If you like my video, then like it, share it, and subscribe it. Thank you.